Hey YouTube, it's me, Rosen, and I'm here to give you another talk I gave a couple of months ago at the JS Talks conference. It's about rendering techniques, how the web evolved, how we got here, what is the current state, and so on. So without further ado, let's jump right into it. When you first start developing a web application, it might seem quite overwhelming. There are different rendering techniques, architectures, frameworks that support all of the different solutions. So it's quite difficult to choose and to kind of make sense of the different technologies. Hopefully today I'll make sense of all of that and make it a bit clear for you. And by the end of the video, you'll be able to tell which of these techniques that I listed here are actually real and which are fake. So first we'll go through the history for a short while, and then we'll quickly go through all the different solutions that evolved, what are the problems they solved, what are the problems they posed, and we'll see how we got here. We'll talk a little bit about user experience, developer experience, and in the next video I'll go and dissect each of the different solutions, going in depth, talking about what are the tools that help us develop them, what are the pros, what are the cons, what are the use cases, and so on. So first, there were the dark ages. First we had just Netscape as a browser. It served static HTML. Soon the web started becoming more popular and the need for more dynamic content occurred. So PHP was involved, and with that we had server-side scripting. The server was doing the rendering. We had the ability to have a more dynamic content based on user inputs, and with each new page we had a page refresh and we had a brand new HTML served. The web continued evolving. We had JavaScript that was introduced into the browser to solve that interactivity need. Now we didn't need to refresh the page in order to get new content. We could have interactivity inside the page. The first standard was approved, ECMAScript 3, and that happened all before the .com bubble. So for quite a while, for the next 10 years, the development of the web technologies kind of slowed down, and this was the status quo for a while. And before we move to all of the new fancy cool frameworks and technologies and rendering patterns, I just kind of want to anticlimactically stop for a little bit and point out that this is the status quo today. There are different statistics, but if you think about it, CMS systems, content management systems, still rule the web today. Popular one is WordPress. It's built on top using PHP, and other languages and frameworks that support multi-page applications are very popular, such as Ruby on Rails, Django with Python, and Laravel for PHP. And the modern frameworks such as React only take a small portion of the web applications, or the small portion of the web applications are built using them. And for the next 10 years, this was, as I said, the prevalent approach for developing web applications. The heavy lifting is done on the server and small interactivity is sprinkled on the client. This approach is very performant. However, it is slow to develop. There is duplicated logic. Think about having dynamic mobile phone number fields. You need to have the whole logic for validation, displaying the fields, displaying the errors, and so on, done both on the server and on the client. And this is error prone. So what came to help the developers and improve not only their experience, but also the user's experience? These were the single page applications. First major popular one was Angular. There was also Knockout that came at that time, but Angular was kind of the first end-to-end framework that gave us the ability to do routing, to do testing, to develop components, and it was all in one place. And it was a huge improvement for the developer, because now you didn't have to think about when the page is rendered, when your element is going to be available, when to attach the event handlers, when should you execute them, what are the corner cases. Now you only had to think about how your component would look like, the data binding was given, and you could focus on developing business logic. So this was not only an improvement for the developers, but also for the users. Now with the involvement of the JavaScript and the new ECMAScript 5 standard, web applications became even more interactive. Now that more of the state was on the front end, you didn't need to be that chatty and go all the time to the server, and the rendering and interactivity are done in one place. For the users, you didn't have to refresh the page on each URL change. This is handled by the framework, and content is displayed dynamically. The apps are now highly interactive. And for the developers, unified mental model, you could quickly scale, quickly develop, and it's all done in one place. You don't have to duplicate logic, think about what should be done on the server, what on the client, and so on. Soon other frameworks followed. React became the most popular one. Other frameworks emerged such as Solid, Svelte, Vue, and countless other frameworks. And it was all good for a while. However, each new framework looks very compelling at the beginning. It's always faster than the previous one, but this is because the showcases are typically very small. As the applications grew, we started to introduce dependencies that solve common problems. Also, the frameworks grew because some of these common problems need to be integrated in the framework. All of the frameworks look compelling at the beginning. However, as the applications needed to be more complex and grow in size, these frameworks started performing poorly. That led to downgrading the user experience. Why not go back to the server and do everything there? Before we start hot potatoing the state, let's do a quick recap. Let's see what exactly is user experience, what do I mean by developer experience, and how do they relate. When it comes to rendering, I think that using Core Web Vitals as a guide is quite sensible. These are metrics introduced by Google, and they can be used to measure the performance of the web application, and they have different thresholds and tell us how different parts of the rendering process perform. I think it's easier to look at an example page load in order to have a better understanding of them. First, we have the time to first byte. This is the time from when you enter the URL till you have the first byte of information about your web page. The first paint is the first thing that is rendered. First contentful paint is the first thing that actually means something to the user. The largest contentful paint is the largest element painted, and it gives us a rough estimate of how much time actually the page takes to load. Then we have the first input delay and the time to interact with the page. They are pretty self-explanatory. And my favorite one is the layout shift. My favorite part of the user experience is when I try to click on an element and it jumps 200 pixels down. Yeah, this is everyone's favorite, I think. And then when it comes to developer experience, these are some, again, rough guidelines on what we should think about and look at when we discuss each solution. But we want fast build times. We could have quick deployments, quick iterations and deployment. We also need to think about server costs, as some of the solutions you see are quite performant, but also quite expensive. We also need to think about the ability to build dynamic content, and not only that, but do it performantly. Other things to think about are the uptime, the infrastructure, how easy it is to roll back, and all of these help us estimate when thinking about should we go with that solution. This is a subjective graph of how DX and UX relate to each other with each new technology introduced. I stole that from a presentation in a quick conference, but I pretty much agree with it. I think that when a new pattern is introduced, typically it solves a user experience problem that is present. For example, if you look at when first JavaScript was introduced, it was a great improvement because now we had the ability to make the applications more interactive. However, the developers needed time to learn how to do that. They needed to learn how to introduce the common patterns emerged, the libraries emerged that help the development speed up, so the development improved with time. However, the user experience downgraded. Then we had rich internet applications, which are thankfully now dead. For example, Flash applications, they were user experience improvement in terms that now you had kind of the best interactivity possible. You could play games in a browser and so on. However, for the developers, it takes time to learn all of that, develop libraries, speed up the development process. Then with the single page applications, again, you needed to learn the framework. You needed time to think about how to store the state, when to call the server, how to build all the different pages. So the apps became quite large, the dependencies started growing, and we started doing local optimizations, which kind of improved the UX for a while, but then the DX started to suffer again because we need to do all of this by hand. Think of your favorite framework, it always has 10 ways to improve the performance. And I think this cycle can be explained in this diagram. There's a new pattern, there's a learning curve for the developers. Libraries start to emerge that improve the developer experience because they have solutions to common problems and you can just start using them. However, applications start to grow because now you have all of these dependencies, and then you start doing local optimizations in order to bring the performance of the applications up, which leads to downgrades of the developer experience because now you have to think about performance each step of the way. And this cycle repeats. In the next video, I'll go through each of the different solutions. We'll talk about what is the sequence of the requests, response, and also how much time it takes the browser to do all of the work. We'll talk about different pros, cons, we'll talk about different technologies that support these solutions, and we'll do all of that for each of the different approaches that we talked about so far, but also see what new approaches emerged. And finally, we'll see what is the common problem for some of them, what might be the solution, and what the future might hold for us. Thank you for your time. Please tell me in the comments what you think about my point of view of how the web development evolved and how developer experience and user experience relate to each other, and about the dance between the client and server. And see you in the next one.